Hello, this is Awab Akib, and today we're going to discuss the pre-release material of May-June 2020, paper 22. This paper is relatively simpler than the last year's, so let's get into the problem. So there is, in this scenario, we have a car park and we have customers coming in and going out of the car park all the time. So what's happening is you have weekdays and you have some timings, and then you have a discount. So these three are our major concerns in the problem. Okay, now what's going to happen is the customer comes at the parking, and before entering he enters the day, the current day. He has to enter that. Okay, then he'll enter the arrival time. So we have two thresholds. One is between 8 to 15:59 and the other one is 16 to midnight. And there won't be any parking between midnight all the way to 8. So that is basically 12 a.m. up to 8 a.m. there won't be any parking. Okay, so these hours have to be valid. Now the other thing that we have to do is, for every customer, once the day has been entered, the maximum hours he or she has to stay has been entered, then you'll give a corresponding price. Okay, so for example, if somebody enters the parking lot at, let's say, Thursday at 9, so he wants to park in for 1 hour, so the total rate would be 10 into 1, that is $10. Okay, or whatever the unit is. And if someone joins after 16, let's say they come around 19, then up till midnight they'll only be charged with $2. Okay, this is a fixed rate now. So as soon as the clock hits 16, you'll be just charging $2 for all the way up to midnight. So that is a total of 7 hours. Okay, 16 all the way to 24 or 23:59. That is exactly 7 hours. Okay, let's jump into the first task. In the first task, we have to input the day, the hour of arrival, which must be only the first 2 digits. Okay, so an easy way to do this is just to get the left 2 most digits, and after that we have to also enter the number of hours to leave the car. Okay, now that depends on each day. Like on Monday you cannot leave for more than 2 hours. Okay, similarly on Sunday you can leave for up to 8 hours. And after that you'll enter a frequent parking number if applicable. Okay, now first we enter the day. Okay, we'll do the input. While true, this is basically just a forever loop. Okay, it's up to you if you just want the input couple of times. Now once we're here, if the day is in the list of days. Now what is this? This is the list that I declared above. Okay, this one. So if it is in the list, let's say I entered Monday. Monday is in the list, right? Then I'll go to this line. Now here I'll enter the arrival. Arrival was the time of arrival. Okay, it should be between this or it should be between this. So we'll be having a check of it, from 00 to 0800. Okay, it should not be loud because the parking is closed at that time. Now to get the first 2 digits, I simply converted this in I didn't really convert this. I just put 1 colon 2. That means get me the first 2 letters of the string. Okay, and I also declared arrival as a string. See this? Okay, so this is a string. Now once I've done with this, I have to ask for the hours of parking. Okay, now let's say if somebody enters on Sunday and wants to park for 10 hours, that cannot be allowed. Okay, because the limit is 8. So we are going to check for that, but we just let the user enter. Now here is the modulus 11 calculation. So what I've done is I first asked if the user wants to input a frequent parking number, because like I said before, it's not an obligation. It's written in the question as well. It's here somewhere. Yeah, if they enter the number correctly, the customer will get a discount, and it's not obligatory. But if somebody enters and it doesn't match, they won't get any discount. All right, So if they have an FPN number, they'll enter and I'll give them a choice. Now if the choice is 1, that means they have a frequent parking number. Alright, so we have the pseudocode in front of us for check digit calculation by modulus 11. Alright, so the procedure that we're going to follow for this part is very interesting. So let's go ahead and assume that the FPN in our case is 1, 2, 3, 4. Now how it works is basically you first write the number, you assign some weights starting from the leftmost side. So in our case it would be 3, 2, 3, 4, 5 like this. Okay, in some cases, in some solutions the algorithm starts from 1, the weights start from 1, but we can start them from 2 as well. Okay, so we're sticking with this this way. Anyways, so once you have the weights, you multiply them with their respective numbers and then you find the sum. Once you have the sum, you take the modulus of sum by 11, and whatever the remainder is subtracted from 11, and that is your check digit. And that's exactly what we're doing in the pseudocode. The approach we used is very interesting. When you take modulus of 10 with anything, you basically return the last digit. Okay, how? Let's see. So 10, 23, 20, and you get 4 as the remainder. And what is 4? The last digit, right? And if you divide anything by 10, you basically get the whole number except the last digit. So like we did. Okay, so this is the result of 10, 1, 2, 3, 4 over 10, and this is the result of 1, 2, 3, 4 modulus 10. This is the sign for modulus, the percentage sign. Okay, now what in this part, what we're trying to do is we get one number, we multiply it by weight, then we get the other number, and the final number. So let's make a small trace table. We have FPN, we have position, we have digit, and we have the sum. Okay, I intentionally named sum as M because in Python it is a reserved keyword. Okay, but this is pseudocode, so I'm using the same anyways. Alright, so FPN is 1, 2, 3, 4. You can use any number, but this is just for the sake of example. Now position is initially 5. Why is position 5? Like I explained, since we're starting the weights from 2, so the last weight would be definitely 5, because we only have 4 digits, so we already know that, so the weight would be 5. Now digit is equal to FPN modulus 10. So when you do 1, 2, 3, 4 modulus 10, you get 4, right? I explained this here. So you got 4 here, and then you say sum is equal to digit into position plus sum. Sum was initially 0, we got it from here. Okay, so here sum should be equal to 0. It's actually declared above in the pseudocode. Okay, like this. Sum is initially 0, so digit into position is 20. 5 into 4 is 20, right? So the sum is 20, and then position is equal to position minus 1, so you get 4 here. Why did I subtract? Because from this weight we are going to this weight, since we are moving backwards. Now for the next part, I want to get the whole number except the last digit, right? So for that we are going to divide it by 10 like we did before here. So when I divide anything by 10, what do I get? The whole number except the last digit. So I got 1, 2, 3. So what is saved in FPN now? 1, 2, 3. And from here I go back to the while loop. Is FPN greater than 0? Yes. Now digit is equal to FPN modulus 10. Now what is 1, 2, 3 modulus 10? We get 3. Okay, the last digit. And sum is equal to digit into position plus sum. So 4 plus 3 is 12. And what was the previous value of sum? We had 20. So 12 plus 20 gives us 32, right? And then position is equal to position minus 1, which gives us 3. And FPN is equal to FPN by 10. This int basically means to ignore the we only want the we only want the integer value. Okay, so we are going to not delve into the decimals or float part. So 1, 2, 3 divided by 10 returns us 1 2, and off we go here again. So digit is equal to, again, FPN modulus 10, modulus of 12 by 10 is 2, so the digit is 2, and sum is 3 into 2 is 6. The previous sum was 32 now, so 3 into 2 is 6, 6 plus 32 is 38. So we got 38 here, and position is equal to -1, so we get to the second position. So far we have done this, and this now as well, and then finally we are going to divide it by 10. So what's left now? When we do 12 divided by 10, I am only left with the last digit, that is 1. Is FPN greater than 0? Yes. And this is our last iteration, because next time 1 divided by 10 would be less than 0. So digit is FPN modulus 10. So 1 is the number, and if we take modulus by 10, we get 1. Okay. So here we have 1 now, in digit we have 1 now. So sum is equal to digit into position. So 2 into 1 is 2, and the previous sum was 38. So 38 plus 2 is 40. So the new sum is 40 now, and we are going to subtract the position by 1. So we get 1, and FPN by 10. So 1 by 10 is 0.1, and next time we go, the condition is not satisfied now. So we go to mod is equal to sum 11. Now in this step, like I mentioned before, this is the final step. Now we take the modulus by 11, and then we're going to subtract for the check digit. So 40 modulus 11, we get 33. 10 minus 7 is 3, and this is your remainder, right? And finally when you subtract, you will replace r with the 7, and we get 11 minus 7 is basically 4. So 11 is our check digit. So these are the steps that we're going to follow to calculate the check digit for in the case of modulus 11, as requested. Now we just have to get inputs and just apply the relevant checks. So if we go to the pseudocode, we have discussed this already in the Python code. This is exactly the same mapping of it here, except with changes of some of the syntax. Now here we are actually going to place the checks. If you go above, there are two ranges, right, that we discussed: 8 to 15 and 16 to 0. 16 to 23. This should be initially 23, because at 23:59 plus 1 minute you get 0000. That is basically midnight. Okay, so since we're getting the two numbers, the first two digits of every arrival time, so you are going to stick with 16 to 23 and 8 to 15. Now here is the simple check. If arrival is greater than or equal to 8 and between 15, then you're going to check for the check digit. Okay, I'm assuming it is 4. It could be any. Okay, it would be saved in the system beforehand. So if it is actually correct, you get the discount of 10%, because it's in this time. So if you see here, the discount is 10% at all other arrival times except for 16 to midnight. Now why did I put 9 there? It's simple. 100 minus 10% is actually 90%, right? So this will directly give you the remainder with the the discount already deducted. Simple math. Okay, so otherwise, if the check digit is wrong, you basically put the discount as 1. Well, anything multiplied by 1 is actually the same, so no discount. And in the other case, now we'll do with the days. So we have found the discount already. Now we'll go with the actual price of the days. So we have all of these days. We are only going to discuss the 3. So first of all, it's Monday. Now if the day is equal to Monday and the max days between is less than or equal to 2. Now where is this 2 coming from? If you see here, this is the max stay in hours. Okay, so it has to be less than or equal to 2. Then your price per hour would be 10. How 10? This is just the simple mapping. Okay, so I'm not doing anything here at all. It's simple if and else conditions. Else if the day is Saturday and max day is less than or equal to 4. If the day is Saturday and it is less than or equal to 4, then between 8 to 16, I'll give the price per hour as $3 or whatever currency you're using. And similarly for Sunday, it would be $2 per hour. Now if none of these conditions are true, basically if you see the and is specifying that the day must be Monday and this day must be less than equal to 2. Now if none of these conditions are true, if we do them for all the weekdays, then it means that they are exceeding the maximum number of hours allotted to each day, because we have already checked for the day here. It was here, okay. If the day is in the list of days, only then we proceed, and you can see all of this code is nested inside this if statement. That is saying only if this if statement was true, then we are executing this code. So then I simply print max hours allowed Monday to Saturday 4 and Sunday 8, so the user can re-enter the data with appropriate information. Else if, okay, so this if is nested. This if is the counter of this one. So if this was the first range 8 to 15, now the other range is 7 to 16 to midnight. Okay, so this is from 16 to midnight, and as I said before, it should be 23 because we are not counting 24 because of the first 2 digits, otherwise it would be midnight. And if the max stays less than equal to 7, now what do I mean by that? Like I mentioned before, from 16 all the way to 23 we have 7 hours, and you can see there is no max stay in hours. It says up to midnight. So if somebody comes at 16 all the way to midnight, you'll have exactly 7 hours. Okay, so you have to be in between that range. That's what this is basically implying, this max stay. So 16, 17, 18 and so on, it must be less than equal to 7 hours. Now again, if the check digit is applied, if it is correct, then you are going to get 50% discount. Now 100 minus 50 is 50%, so I write 0.5 here. Otherwise the same 1, and anything multiplied by 1 is actually the same, so no discount. And the price per hour is set to 2. The reason is for all of the cars parked in this range, they'll get a $2 price per hour. Okay, so we will not be doing anything here. Otherwise, okay, so since we did these 2 conditions, so between the first range, otherwise between the second range. Now if somebody enters 3:56, we are going to print parking closed between midnight and 7:59 a.m. all right, and we are simply going to continue in our case in the pseudocode is meaning we go back to the while loop. Okay, we go back to the top of the loop. You can write any keyword here. You can say go back to the while loop, go to the first iteration, go to the first line of while loop, and so on. This is basically the Python syntax, so we can use it in pseudocode as well, no worries. We are going to end if, and finally we are going to find the price. Now how are we finding the price? Simple as it is. So if I have on Monday, if I have 2 hours and the price per hour is 10, so 10 into 2 is $20, right? And then I simply multiply the discount straight away because I've already found the discount above the percentage. If I multiply them, I get the discount, and then I print it. Alright, now task 2 is very simple. It is just an extension of task 1, and what we have to do is basically they want us to find the total of each day, that every parking fee summed up together. Okay, now every customer would be allowed to input the amount they paid. I don't know why this doesn't make sense, but it's just for the sake of the simulation as they've mentioned. So if you have maybe let's say a $20 parking fee, now as a user you're going to enter a fee again. So if you enter $25, you won't get any change. Okay, this is quite a greedy system, so you won't get any change. So 25 would be added to the whole day's sum counter. Okay, so if the previous transaction was also of $25, the total would be raised to $50. Okay, and this would keep on going for the whole day. That's what they're saying. Now the amount must be greater than or equal to the one that is shown on the screen. Okay, so it has to be, if for example it is 10, then it should be 11 or 10.1, but not less than that. Okay, now we must also display the total at the end of the day. Okay, so our day basically ends at no parking is allowed between midnight and 8, so our day ends at midnight, that is 00:00, and we want to reset the counter at before the start of the day. It's mentioned here. So yeah, now our start of the day is essentially at 8, okay, or 7:59. So we want to reset our counter before that. Now this is very simple. We are going to use exactly the same code as above from the task 1, and we are only going to add 2 small changes. Now here we find the final price of that the customer has to pay, okay, at the minimum price that is shown on the screen. Now in the question it says in the simulation you'll have, as a user, you'll have to input the value back. So each customer inputs the amount paid, whatever they paid. Okay, so I just create an input as customer input. I label it as float here above, okay, 0.0 initially set to null. And if customer input is greater than or equal to final price, only then you are going to add it to the day total. And what was day total? Day total is nothing, just a day counter. I have declared it above. Okay, I haven't, so we'll get it here. Float day total 0.0. Alright, so if the amount is, the valid, whatever the user paid, if it is more than that, then we are going to add it to the day total. Otherwise we are going to tell the user to kindly enter the required amount or more, okay, and then we are going to simply end if. Now for the sake of resetting and for the sake of finding the total for the day, I'm just assuming that we are getting the time somehow in the system, okay. Since they've not mentioned anything in the question, let's assume you're getting time from some built-in function. So if the time is equal to midnight, then you are going to say total for today is the day total, okay. Simple as that, nothing tricky. Otherwise, as soon as the clock hits 7:59, because our parking lot is opening at 8, so we want to refresh our counter before that, I'll set the day total to 0 and I'll say total for the day resetted. You don't want to print this, okay, since they've not asked. So this is very simple. Task 2, we only made 4 or 5 lines of changes. I've also written the Python script for this. It's also uploaded. And now on to the task 3, which is a bit tricky, but still pretty much doable. So in task 3, what we are asked to do is, some users complain that if they park before 16, they have to pay a lot of fee. Okay, so we are going to be fair now. We won't ask the users, we won't be overcharging the users. So what we'll do is we'll tell them fair rate now. So how we're going to do that is we will calculate the price before the 16 and then add the evening charge. Okay, so if somebody arrives at 14:45, okay, so let's use this example. Okay, so if somebody comes at 14:45, sorry, so 14:45 is the arrival time, okay, 80. Since we only take the first 2 digits, so we get 14, and we have to check if it, what is the question statement is, it has to be before 16. You have to check before 16 or currently at 16, all right, and then you are going to add the evening charge. So 14 to 16, how many hours do you get? 16 minus 14 is 2 hours. And for these 2 hours, you are going to charge the variable rate for each day, okay, within this section. And as soon as 16, the clock goes more than 16, you'll only charge a flat rate of $2, not more than that. Essentially, previously what we were doing was we were not counting the end time, okay. We were just saying if any car enters within this range, you are going to charge these many dollars, okay. So see again, if on Sunday somebody parked at 14:45 for 5 hours, so if on Sunday somebody parked for 5 hours at 14:45, that would have meant 5 hours multiplied by 2 is 10. Now what we will do instead is, so for the 2 hours we'll charge them 2 multiplied by 2 as $4, okay, because for Sunday, for this range of 8 to 16, we'll only charge $2 per hour. So we have 14th hour, we have 15th, we have 16, okay, all of these are hours. Now the user stayed for how much time? He stayed for 5 hours. So let's put all the hours: 14, 15, 16, 17, 18 and 19. Okay, all of these hours. Now all the way for 14 to 16, from 14 to 15, how much are you going to charge? $2. Okay, so you add 2 plus. Okay, and then for 15 to 16, since it's another hour, you're going to again charge 2. So what that gives you? $4. Okay, so you charged $4 for 2 hours. Now as soon as the clock hits more than 16, we decided we'll be very fair now. We won't be overcharging them, so we'll start offering them a flat rate, as was discussed in the question, and like we did in task 1 as well. So for all these hours, you are only going to charge $2. Okay, no matter how long they stay, as long as it's between the parking times. So what do you get? 4 plus 2 is 6. That's essentially what the question is already given us. Okay, now how we are going to do this in pseudocode? So we are not going to change anything from task 1, we are just basically extending it. So here is the small change. So let me take a screenshot of this. Okay, so we're here now. So if arrival plus max stays greater than equal to 16, arrival was the number of hours, which are in our case would be 14 or any, and max stays the number of hours that are given. Okay, so we are going to use the questions example. So the person arrived at 14:45 and stayed for 15 hours. Now we have to check if it exceeds 16, right? That's what we did above. So it must not be more. If it is more than 16, we charge a flat fee. So it is equal to or greater than 16, yes. Then you're going to say max stay is equal to 16 minus arrival. Now what does this mean? So yeah, 16, and what was the arrival? It arrived at 14. So what was the difference? 2 hours. Exactly what we did here. Okay, these 2 hours. So now my max stay is updated to 2, and in my final price, what I'm doing is I'm multiplying the price per hour with the maximum stay. So the price per hour is, for Sunday, was $2 per hour. Okay, so this is $2 per hour, and my max stay is initially 2 now. So 2 into 2 is 4, and 4 plus 2 is 6, and then I'm going to apply the discount, whatever it is. Okay, this is very simple. So another example, let's say I came at 12 and I stayed for 6 hours. Okay, so that means I 12, 13, 14, 15, 1, 2, 3, 4, 5, 6. Okay, I stayed for these many hours. So all the way from 12 to 16, let's say I came on a Monday. Okay, so let's check now. On Monday, you can only stay for 2 hours. Okay, so then let's change this to Thursday, to a Sunday then. Okay, so we stayed for 6 hours. Now all the way from 12 to 16, what is the rate? It is $2 per hour. Okay, so that means plus 2 plus 2 plus 2 plus 2, that is 4 into $8. Okay, in total. Now as soon as the clock hits 16 and goes to midnight, I'm just going to charge a total of $2 for the parking. Okay, so this gets me $10 in total. Okay, that's exactly what I did. I just found the difference between the 16th hour with the hour they placed their car in the parking, and then I just added that many added that to the price, and this too is the flat price. You can save it in a variable called price or flat price. I just directly added it. Okay, yes, so this was May-June 2020 pre-release material. If let's also see the Python file for this. Okay, so the same thing that we did above. Let's run this once. So I'm on a Monday. Let's use Sunday, the example that we did now. So I came at 12. I stayed for 6 hours. My parking number was 1234, so I won't be getting any discount. So I was charged a total of 9. I think we got the discount here. Let's check. Yes, indeed we got the discount. My check date is set to check if it is equal to 4, and we actually got 4, so we got a 50% discount. Okay, so that's why the price is $9 now. So this was the task 3. It is pretty simple.